Hello dear students. So in the last class, we have seen what is a process. So just I want to recapitulate some points about the process. So here you represent any process in thermodynamic. So we need to connect numbers of intermediate thermal equilibrium points. So here from 1 to 2, so we can join this by a distinct form line as because to attain the state point 2 from state point 1, there will be numbers of intermediate thermal equilibrium points. So when we will join all those points, so you will get this process. So this process is a reversible process as because numbers of thermal equilibrium will comprise to this process. So if this process is not composed of thermal equilibrium points, so the points will deviate. If the points will deviate from the thermal equilibrium, then we cannot join these 2 points. So then we will be using some dotted lines or dotted points to represent the state 1 and state 2, and that process which will be connected from 1 to 2, that will be a reversible process. Means in going back from 2 to 1, so we cannot attain the same system or same unit surroundings. So this is the basic definition of this process or the salient features of a thermodynamic process. So here in this lecture we will study one important topic, that is temperature. So after studying the thermal equilibrium and the zeroth law of temperature, so we can conclude about a very important parameter, that is temperature. The thermal equilibrium state can be defined by a parameter and which is sensed or which is defined by this temperature scale. In microscopic point of approach, this temperature is nothing but the average kinetic energy of a particular molecule, and in macroscopic approach, this is the average energy of molecules. So generally we define temperature as the parameter or as the property by which it flows from one body to another body. To understand the temperature, so there is one particular branch of science that is called as thermometry. So where the thermometer measures this parameter and finds out some value with respect to some material, and this will give some output, and after measurement the temperature of the system, it is achieved. So various thermometers are basically used. These are constant volume gas thermometer, constant pressure gas thermometer, electrical resistance thermometer, then thermocouple, then mercury in glass thermometer. So where the thermometric properties are also listed. So these devices will give rise to an output, and that output will be a measure of temperature. So I will not go to the detail of all these thermometers. The important point, which is the thermometric property of each of the thermometers, here it is listed. So you can go through Pekenak book where you will get the idea of each of the thermometer in detail. So as I have told you that zeroth law of thermodynamics give rise to an important property of a system which is known as temperature. So this temperature can be sensed, this can be felt, and this is normally defined as the parameter or property through which heat flows. So heat is a kind of energy, so which unit is joule. So I have told you the microscopic and macroscopic definition of this temperature. So thermometry is the branch of science where the measurement of temperature is studied. Basically, this temperature is measured on three basic scales. One is for Celsius scale, another is Fahrenheit scale, and the last one is Kelvin scale. There are various types of other scales also available, but in general, so we will use these three basic scales to measure the temperature of any system. So to find out any temperature of a system, so we can use any of these scales. But if you are asked what is the interrelation or how you can convert this Celsius to Fahrenheit or Fahrenheit to Kelvin, so there should be some relation. If you know that relation, so if you are having one system in Celsius, so you can convert the temperature to Fahrenheit as well as to Kelvin. So in Celsius, so C, we will denote the temperature is degree centigrade, degree capital C. And in Fahrenheit, we will write the temperature unit as just like some value and Fahrenheit, and then Kelvin with some value and with capital K, Kelvin. So small k is used for kilopascal, kilowatt, and here capital K is for temperature scale. To find out the relation in between these three, let us consider the ice point and the boiling point of water. So in degree centigrade, the ice point or the melting point of water is 0 degree centigrade. So we will mark it as the basis 0 degree centigrade, and the boiling point of water is 100 degree centigrade. So in Celsius scale, so these are the two parameters which will define the freezing point and the boiling point of water. So Fahrenheit scale defines the ice point of water to be 32 Fahrenheit and the melting point of water or boiling point of water basically it is 212 Fahrenheit. Similarly in Kelvin scale, so the freezing point of water it is 273.15 Kelvin and the boiling point of water is considered to be 373.15 Kelvin. Here the difference of temperatures are same for degree centigrade, centigrade scale and Kelvin scale. Okay, but here the difference is a little bit more. Okay, so to find out the relation in between the centigrade scale or Celsius scale and the Fahrenheit scale, so let us assume in this axis, horizontal axis, so we have taken centigrade or Celsius scale, and in vertical axis, so we will draw this Fahrenheit scale. So the 0 degree centigrade will define the ice point of water and 100 degree centigrade will define the boiling point of water. Similarly, 32 Fahrenheit will define the ice point of water, and 212 Fahrenheit will define the boiling point of water. So if you just project these 2 points, so they will meet at this point. Okay, so you can see the dotted lines. So this point is the meeting point of these two extreme lines. Okay, these horizontal and vertical lines. Now I will connect this point to this point, okay, with a straight line, with a line. Now let us consider that we need to find out the temperature at this point, as because this line will be a coordinate mixture of this Celsius and Fahrenheit. So every point on this line can be represented by C1, F1, C2, F2, C3, F3, like these arbitrary points. So let us consider this point is C and F. Okay, so we will move C units in the horizontal line and F unit in the vertical line, then we will get this point. Okay, so here C is, let us consider this point, and F is, let us consider this point. So we need to find out the relation in between these 2 points, okay, in terms of Celsius and Fahrenheit. So let us join this triangle. Okay, then you can join this line also by dotted lines. Okay, though it looks like a firm distinct line, but you need to join it by a dotted line, as because this is the only firm distinct line. Okay, as because we are concerning this on this temperature. Okay, so as because the small triangle and the bigger triangle is similar, so what we can write from the small triangle and from this bigger triangle, so this side divided by this side, this ratio will be equals to this side divided by the bigger side. Okay, from this vertex this side, and from this vertex this bigger side, that ratio will be equal. So what will be the value of this side? So up to this much, from here it is F, and up to this much it is 32. So F minus 32 divided by, here it is how much, 212 minus 32. So F minus 32, so this side will be 212 minus 32 equals to C minus 0, this small side divided by the bigger side. So 100 minus 0. So as because these two triangles are similar, so we can write like this way. Okay, so if you just simplify this one, F minus 32 will be remain same. So this will be 212 minus 32 will be 180. 180 I have written here. So C minus 0 it is C, 100 minus 0 it is 100. So if you just simplify this one, it will be C upon 5 equals to F minus 32 by 9. So this is the relation in between Celsius scale and Fahrenheit scale. So if one system is given at centigrade scale, so you can find out the temperature at Fahrenheit scale by this relation. Okay, so it is very simple. So F minus 32, okay, F minus 32 divided by 212 minus 32. Okay, so this side divided by this side will be equals to this side divided by the bigger side. Okay, so that way you need to find out the interconversion of temperatures. Now what you have got, so this relation you have got from this same graph. Okay, so this is, if you, it is marked as 1, so from 1 what you can write, so F is what, C and F are the readings. Okay, so what we have got, we have got F as the reading from the Fahrenheit scale, so we can find out what will be the reading in centigrade scale. Okay, so reading minus ice point, because 32 is the ice point for Fahrenheit scale. 212, what is this? This is the boiling point or steam point for Fahrenheit scale, minus 100 is what? Sorry, I'm very much sorry. This is 32. F minus 32, 212 minus 32. Okay, just you recorrect this one. So steam point 212 is steam point, 32. This is 32. 32 is the ice point. Okay, ice point. So it will be that ratio will be constant. So this ratio equals to this ratio will be constant. So that means reading value minus ice point, boiling point or steam point minus ice point. This is 32. Okay, not 100. Just you recorrect this one. So it will be a constant. So for any scale. So thus for centigrade scale it will be C minus 0, C minus ice point, then steam point 100 minus ice point 0. So for Fahrenheit scale also it will be same. For any scale, whatever scale you will take, that this ratio will be same. So for Fahrenheit scale it is reading minus 32 ice point, then boiling point minus ice point. Okay, for Kelvin scale also, so K is the reading minus the ice point 273.15 divided by the melting point or boiling point minus the ice point. Okay, so this will give you, so in between this centigrade scale and the Kelvin scale, if you just want to find out the relation, so you will get this one. So K equals to C minus C by 100, C by 100, C minus 0 equals to C, 100 minus 0 equals to 100. My equals to K minus 273.15 divided by 100. Okay, so 100 will be cancelled out. So K will be equals to C plus 273.15. So this is the relation between Kelvin scale and centigrade scale or Celsius scale. Okay, so for example you can solve this problem. So convert 27 degrees centigrade in Kelvin and in Fahrenheit. Okay, so we will use this relation because this is the basic relation, better you just use this one. Okay, so reading, whatever reading will be 27 degrees centigrade. So this we will put it here. So 27 minus 0, so 100 minus 0, F minus 32, 212 minus 32. This will be the boiling point, this will be the ice point, and this will be the reading point, and this will be the ice point. Okay, so finally you will get Fahrenheit temperature scale, and here the centigrade scale it is written, and Kelvin scale, this ratio will be equal. So from here the Kelvin value you can find it out. So this way you can find out the value of the Fahrenheit and the Kelvin. So this is one homework for you, just you find out these two values. Everything it is done, just you need to calculate it. Okay, so dear students, I think from today's lecture, so you will be easily convert the temperature scale in one form to another. Okay, in the next slide, here you can see there is a common relationship formula. Okay, so from this formula also you can solve the problems, but I suggest you to apply that basic formula, okay, which we have denoted by the graphical form, okay, by the use of the similar triangle. So that way you will not forget that formula. Okay, so thank you dear students for listening, and I will be uploading this video in the Google Classroom. So below that class you just post your doubts or queries by today itself. Okay, by today midnight you just post it, so I will clear it to you by today or by tomorrow morning time. Thank you dear students.